Okay, let's review for exam 1. So this is a version of mock exam, which means very similar to the true exam. So we have 15 questions in total. So I'm going to go over each one of them. Let's see the first one. The first one, we need to find equation of the line, right? Remember, when we say equation of the line, that means probably we have this formula in our head, or we have this formula in our head. But the first one we call standard equation of a line. And the second one is we call slope and intercept form. Right? We want to find the equation of the line which is perpendicular. Remember what does perpendicular mean? If a line goes this way, line perpendicular to it makes 90 degrees. So one line is given, and this is in slope and intercept form. What's the slope? Slope is 1. The number before x is invisible, is 1. So if two lines are perpendicular, right, the slope of this one is called M1, slope of this one is called M2. So M1 equals to negative 1 over M2, which is opposite inverse, right? Opposite means if one is positive, the other one is negative. If one is negative, the other one is positive. So opposite. Inverse. Inverse means multiplicative inverse. What's the inverse of half? The inverse half is 2, because half times 2 is 1. What's the inverse of 2 over 3? The inverse of 2 over 3 is 3 over 2. Because we get 6 over 6, which is 1. So two numbers multiply each other, gets 1. We call multiplicative inverse. So when two lines are perpendicular to each other, the slope, the relationship of the slope, one slope is the opposite inverse of the other. So the slope of this one is given line is 1. So the other one should be, let's use M. Should be opposite, because 1 is positive, opposite inverse, 1 over 1. Well, 1 over 1 just 1. So the slope is negative 1. Then this line passing through this point, 2, 3. So another one is called the slope point formula. Remember, when we find the slope, we say m equals y2 minus y1 divided by x2 minus x1. And this one we can rewrite, we multiply x2 minus x1 on both sides. We can rewrite it as y2 minus y1 equals to m times x2 minus x1. Well, if we think about x and y, so we can ignore these two. Right. So we have this slope point formula. So now we know the slope is m. And we're given this 2, 3, right? Let's call this x1, y1. So we use this formula. We have y minus 3 equals negative 1 times x minus 2. We simplify a little bit. So we have y minus 3 equals negative 1 times x, that's negative x, negative 1 times negative 2, positive 2. We move this negative 3 to the other side, to y equals negative x plus 5. So the answer is this. Okay, let's say 2. So the first one is 5 points. The second one is 10 points. The second one, we're given equation, right? This equation V represents the amount of money for the smartphone, and T represents the time in years. So given this equation, and we are asked to first sketch the graph of this equation. Well, to sketch this graph, we only need 2 points. So the first point, let's see, we get T, we assign T to be 0. Then V equals to negative 500 times 0 would be 0 plus 12,000. So V just equals to 12,000. So we get 1 point, right? 0, 12,000. Oh, I wrote one more zero, only 3 zeros. Now let's see t. We can choose t to be any number, right? To be a convenience number. So I'm going to choose t to be 20, right? But if t is 20, let's evaluate v. So we have negative 500 times 20 plus 12,000. Well, we can find y-intercept, x-intercept, right? So in any case, we need 2 points. So in this case, we have negative 10,000 plus 12,000. So I get 2,000. You see why I choose 20? So now I can graph with these 2 points, I can graph. Because this is application, I only need to graph first quadrant. So T, V, V in dollars, and T in years. I only need to graph 2 points. So I have this point, 0, 12,000. So I just graph here. Okay, let's see, this is a point 0, 12,000. And then I need to graph another one, 20 and 2,000. So 20, let's see, 20 is somewhere here. Okay, so this point will be 20, 2,000. So how do I graph 2,000 on this? Well, 12,000 is 6 times 2,000. So I can divide into half. Then each one I can divide it into 1/3. So this will be 2,000, right? So the point will be here. So with these 2 points, I can graph. I just draw a line segment cross these 2 points. Or you can find, maybe you can find this x-intercept, right? For x-intercept, you assign v to be 0. Then you solve for t. Well, let's do that. So you v is 0, I have negative 500t plus 12,000. So t just equals to 12,000 divided by 500, which is 5 goes into 12, 2 times 24, right? So this point here is 24, 0, right? Actually, I got 3 points in this case, right? You only need 2 points to graph this. Okay, I have to move the page. Let me erase everything. Well, now let's see B. B giving us T as 3 years. Okay, so we want to find a V when T is 3. We just plug in 3 for T, plus 12,000. So that's negative 1,500 plus 12,000. Well, we use this 2,000 to subtract 1,500, that's 500. So we get a 10,500. That's it. C is asking when will smartphone value reach 100? So that means V equals 100. Well, we use this equation. So that's negative, so V equals 100 equals to negative 500t plus 12,000. Right, we can move negative 500t to the other side, become positive. Then move 100 to be with 12,000. So 12,000 minus 100 would be 11,900. Then t equals to 11,900 divided by 500. Cancel those 2 zeros. So what do we get? We get a 20. Right, 2. So because 5 goes into 11 2 times, then we'll have a 19. That's 3 times. Then we'll have 40. So 23.8 years. Okay, that's for C. So that's for 2. So 2, 10 points. Now let's see 3. Find the general equation. Again, find the equation of the line containing this point and having slope of 10. You can use the slope point formula. Y minus -1 becomes y plus 1 equals to 10 times x minus 0. So get a y equals to 10 y plus 1. Because we need to write this into standard form. We need to write as ax plus by equals c form. So we have 10x, 10 times 0 is 0, just gone. This term just gone. So y, move y to this side, becomes negative y equals to 1. So that's the answer. Okay, let's see 4. State and perform the next elementary row operation that should be performed. Put the matrix in diagonal form. Remember, diagonal form is the diagonals are all ones and other entries are 0. So we only have to do one. We only have to do operation on this -4. Right? Our goal is to make this -4 to be 0. That's pretty simple, right? We do R1 plus 4R3. Right, because 4R3, so this first one is R1, this is R2, the third row is R3. So first we multiply by 4. So remember, we build a bridge, right? We're building bridge here. 4 times 0, 0, 4 times 0, 0, 4 times 1, 4, 4 times 10, 40. Now we add R1 with 4R3. We get a 1, 0, -4 plus 4, bingo, 0. A plus 40, 48. Then the second row doesn't change. The third row doesn't change. And that's it. That's it, just one step. All right. Okay, let's see 5. 5, so we want to find the missing numbers. And this question, so the first row are the same, and then all those are question marks. So I'm going to change a little bit. I'm going to change this one to be 0. I'm going to change this one to be 0. Right? Because on the true exam, those can be any numbers. Then you have to perform the corresponding operations. So I'm changing this one to be 0. I'm changing this one to be 0. So we need to find this number, this number, this number, this number, this number, this number accordingly. Okay, let's see. So let's come here. So first one, we need to change -3 to be 0. Right? So we could do 3R1 plus R2. Right, so 3R1 is our bridge. It will be 3, -9, 12, 27. Then the first row doesn't change. We just write it down. The second row changed, right? So 3 plus -3, bingo, 0. We have achieved this goal. -9 plus 1, -8. 12 plus -3, 9. 27 plus 6, 33. Right, we have found those 3 missing numbers. And then maybe we can do the same time. We want to change this one to be 0, right? This is our second goal. Let me use blue color. So we want to change this one to be 0. So how do we change this one to be 0? Well, we could use R3. So we could build 3R3, right? Then we add R1. So then this will be 3, this will be 3, this will be -9, this will be 3. Now we do R1 plus 3R3. So R1 is this one. right? 1 plus 3, 4. Negative 3 plus 3, bingo, 0. I have achieved my goal. Right? Negative 3 plus 3, 0. 4 plus negative 9, negative 5. 9 plus 3, 12. And that's it. We found all the missing numbers. Let's say 6. So 6 were given this system of equations, but we need to use Gauss-Jordan method. If you use any other method, you don't get any credit. Okay, we have to use Gauss-Jordan method. So Gauss-Jordan method, we want to make a matrix. We only write down the coefficient of the variables. We make sure the coefficients of x and y are lined up. So we write down negative 3, 5, negative 2, 3. Then we put a bar here. Write down 34, write down 31. So this should be our first step. Right, first step. So to use Gauss-Jordan method, elimination method. Then what's our goal? Our goal is to reach 1001 identity matrix on the left-hand side, whatever on this side, right? This represents 1x, this represents 1y. So x value will be this, y value will be this. Okay, let's do that. So I'm gonna erase. So yeah, we won't be able to achieve everything all at once. So let's do this. Oops. So there's the negative 3. Let me change the red color. So let's change this one to be 1 first. Right, let's change this one to be 1. So what do I have to do? I could do negative R1 plus R2. Right? You could use any method. It's just your goal is just change negative 3 to be positive 1. You see, if I do negative R1, let's say negative R1 is my bridge, I would have positive 3 and then negative 5, negative 34. Then I add R2, right? 3 plus negative 2, bingo, I get 1. Negative 5 plus 3, I get negative 2. Let me change back to blue color. So negative 5 plus 3, I get negative 2. Then negative 34 plus 21, I get negative 13. So my next goal, okay, let's rewrite. So I got negative 2, 3, 21. Now my next goal is to change this one to be 0. Change that one to be 0. Let's write here. I don't have a space, so allow me to write here. So the first row, I have negative 1, negative 2, negative 13. Now my second one, I want to change this entry to be 0. So how do I change this entry to be 0? Well, I can build 2R2, right? I build 2R2 from here. So I get 2, I get negative 4, I get negative 26. Then I add to R3. So I get a 2R2 plus, no, 2R1 plus R2. In that case, I have 2 plus negative 2, bingo, 0. Right? Negative 4 plus 3, I get negative 1. Negative 26 plus 21, I get negative 5. Now the second row is solved. Negative y equals negative 5. I can just multiply by negative 1. Right? I can do negative R2 here. So switch this one to be positive. Now, all I have to do is change this one to be 0. So just one more step. So the second row is solved. Y equals to 5. Then this is 1. So how do I make this entry to be 0? I can do R1 plus 2R2. Right? So 2R2, I get 0, I get 2, I get 10. 1 plus 0 is still 1. Negative 2 plus 2, 0. or negative 13 plus 10, negative 3. That's it. It's solved. X equals negative 3, y equals to 5. Now let's see 7. So be careful. You see 6 is 10 points. 7 also 10 points. So this one is saying the Gauss-Jordan elimination method was performed and the matrix was obtained in the end. So we have to determine if the system has a solution or has solutions or have no solution, right? 3 cases. Remember, for every system, 3 cases. 1 solution, 1 unique solution, or infinite many solutions. Infinite many solutions or no solution, right? Only these three cases. So let's see the first one, A. What does A is saying? A is saying X equals to 7, right? And the Y plus Z equals to 3. So we see the second one is a line, right? Y plus Z equals 3. If I have a YZ plane, let's see, this is Y, this is a Z axis. I have this 3, 3. Right, so this is a line. And the X value, you can imagine, right? Your X value come towards you. Right, X axis come towards you. Then you have that plane, ZY plane on X equals 7. So how many solutions? The infinite many points on this line. So that's the second one, right? So this one, A, has infinite many solutions because the solution is a line. Is a line width. Let's see B and C. Oops. Let me move up a little bit. Or B is saying X equals to 4, Y equals to 3, and 0 equals to 1. This is forever wrong, forever not true, right? 0 can never be 1. So no solution for this one. Well, C is saying X equals 3, Y equals to 7, Z equals to 0. One unique solution. Okay, let's say A. A, we're given a 2x2 matrix, B 2x2 matrix. We want to compute AB and BA. Let's compute AB first. So 1, 1, 7, negative 5. That's A. Multiply by 1, 5, 3, 7. Remember when we multiply 2 matrices, we do dot product. So this is 2x2 times 2x2. Our solution, our product should be 2x2. Right, I have 4 spots. I have 2, 2. So the process is to do the dot product. So this entry here comes from dot product this one with this one. So dot product, and I take 1, 1. I dot product with 1, 3. I multiply component wise. 1 times 1 is 1. 1 times 3 is 3. I add those two, so I get 4. And the second one comes 1, 1 dot product with 5 and 7. So 1, 1, 1, 1 dot product with 5 and 7. 1 times 5, 5. 1 times 7, 7. 5 plus 7, 12. The second row comes, the first entry comes from taking this one dot product with the first column. So 7, negative 5, dot product with 1, 3. 1 times 7, 7. Negative 5 times 3, negative 15, plus 7, negative 8. Then 7 comma negative 5, dot product with 5 and 7, well, that's 0. And that's it. So that's A times B. Now let's do B times A. So 1, 5, 3, 7. So we switch the position of those two matrices with 1, 1, 7, negative 5. The process is the same. We do the dot product. of this one. With this one, we also get 2 by 2 matrix with 4 entry. So 1 times 1, 1, 5 times 7, 35, 35 plus 1, 36. Then we dot product with this one. 1 times 1, 1, 5 times 5, 25, 25 plus 1, 26. Then we do 3, 7, dot product 1, 7. 1 times 3, 7 times 7, 49, 49 plus 3, 52. Then 3, 7 times 3, 7 times 1 and 5. 1 times 3, 5 times 7. So 35 times 7, 35. 1 times 3, 3. 35 plus 3, 38. So we see the 4 entries are different from AB. So usually, so we see the matrix multiplication not commutative. The order matters. Okay. Okay, let's see 9. Perform indicator operation, right? This will have 2 by 1 matrix. This is 1 by 1 matrix. So we should get a 2 by 1 matrix. So we take this one, multiply this one, we get 3. Then we do 4 times 3, we get 12. That's it. Because 1 by 1 matrix is just a number. I just multiply by 3. So 10 we perform, so we have addition here, but we have this scalar. So we want to do the scalar first. We multiply this -5 with every entry of the first matrix. So we get -10, -5, -15, -30, 0, -5. Right? Then we add to this second matrix 3, 6, 1, 9, 10, 1. When we add entry wise. Right? We add entry wise. We add a 1, 1 position with 1, 1 position. 1, 2 position with 1, 2 position. We add position entry wise. But we should still have 3 by 2 matrix. So -10 plus 3, -7. -5 plus 6, 1. -15 plus 1, -14. -30 plus 9, -21. 0 plus 10, 10. -5 plus 1, -4. Well, this one we have different size, right? This is 2 by 1 matrix. This is 2 by 2 matrix. So the operation cannot be performed, right? So cannot be performed. Let's see 12. The matrix has no inverse. Has no inverse means the determinant equals 0. How do we find the determinant? We multiply 3 with 7, subtract 21 times x. So 3 times 7, 3 times 7 minus 21 times x. That should be 0. So 21 minus 21x is 0. Or 21x equals 21. So which means x equals to 1. Right? So the only thing is we have to understand when the matrix has no inverse, which means it's a determinant to be 0. So x equals 1. This is 13. Compute the inverse of this 2 by 2 matrix. Use Gauss-Jordan method. All right. So the simple method is A inverse equals 1 over D multiplied by matrix. The matrix is switch the position of 2 and 3. So now you put a negative sign in front of those two ones. So we have to find a D. What is a D? D is 3 times 2, 6, minus 1 times 1, 1. So 5. So the A inverse is 1 over 5, followed by this matrix 2, 3, -1, -1. But 13 wants us to use Gauss-Jordan elimination method. So what is that? Let's do that. We should get the same answer. All right, so answer should be the same. The answer should be this. So use Gauss-Jordan elimination method. So we do this. We write down the matrix A, 3, 1, 1, 2. Then we write down the identity matrix. So which this means A with identity matrix, right? Then our goal is to change this to be 1, 0, 0, 1 identity matrix on this side. Then whatever on this side, that should be A inverse. Okay, so we need to do a row operation. First, we want to change this 3 to be 1 because there's a 1 here. So what do we do? Let's use this spot. Well, we can build a bridge, 2 R2, right? There would be 2, would be 4, would be 0, would be 2. Then we use R1 minus 2 R2. So 3 minus 2 would be 1. 1 minus 4, negative 3. 1 minus 0, 1. 0 minus 2, negative 2. And the second one is just 1, 2, 0, 1. Now our second goal is to change this one to be 0. So we just do R1 minus R2. So we rewrite the first row. So the operation is on the second row. So 1 minus 1, bingo, 0. Negative 3 minus 2, negative 5. 1 minus 0, 1. Negative 2 minus 1, negative 3. Now, let's change this one. So we have, let's change this one to be 0. Oh, it's a little bit difficult, right? Actually, we could do it. Right, we could do negative 5. So we could do R2. Let's do R2 plus minus 2R1. So let's do 2R1. 2R1 is our bridge. So we get 2, negative 6, 2, negative 4. We do minus. We do R2 minus 2R1. So, oh, hold on a second. We don't want to do this, right? Because we're going to change this. So, okay, I guess we have to do the second row first. But if we do this, we're going to change the first entry, but we don't want to change the first entry. So we have to, I'm trying not to get into fractions, but I guess we have to. Okay, so we just do R2 divided by negative 5. So the first row is rewrite the first row, 1, negative 2. And we divide by negative 5, 0, get 1. Get 1 over, so this is negative 1 over 5. This is a positive 3 over 5, because we're dividing by negative 5. Now let's change this one to be 0. So we do R1 plus 3R2. So we build bridge 3R2. We get 0, we get 3, you get negative 3 over 5. We get 9 over 5. So our row operation is R1 plus that. So R1, 1 plus 0, 0, negative 3 plus 3, 0. 1 plus negative 3, well, that's 2 over 5. Negative 2 plus 9 over 5, that's negative 1 over 5. Right, because negative 2 can change to be negative 10 over 5. Negative 10 plus 9 would be negative 1. And the second row, it says 0, 1, we just rewrite it, negative 1 over 5, 3 over 5. And that's it. So this is the A inverse. So this is the use Gauss-Jordan elimination method to find this inverse. You see, this should be exactly the same as before, but before we have 1 over 5. If we want, we can write the inverse of A as 1 over 5, 2, negative 1, -1, 3, exactly the same. All right, so I need to erase this, get space. Now let's see 14. 14, we need to use matrix inverse to solve. When we say matrix inverse, what's in our head? We want to write as AX equals B form, right? So A, then X equals, well, X in this case is XY, equals to A inverse times B. So let's write down A. Well, A is 3, 2, 4, 3, 3. Right, times X is XY equals B. So this should be your first step, right? When you see use matrix inverse method to solve. Now we need to find A inverse. So A inverse equals 1 over D, or determinant. What's the determinant? 3 times 3, 9, minus 2 times 4, 8. It says 1. 1 over 1, we could just ignore it. But anyway, let's write down. So we switch the position of 3 and 3. That happen to be the same. We put a negative sign in front of 2 and 4. -2, -4. So that's our A inverse. We can ignore this 1 divided by 1. 1 divided by 1 is just 1. Okay, then let's multiply by B. That's our A inverse. Let's multiply by B. Or B is 6, 1. So we have 2 by 2 matrix and 2 by 1 matrix. So we should get 2 by 1 matrix. The first one, the first entry comes from dot product, those two. 3, -2, dot product with 6, 1. 3 times 6, 18. -2 times 1, -2. 18 minus 2, 16. The second one comes from this, -4, 3, dot product with 6, 1. -4 times 6, -24, plus 3, -21. And that's it. So that means, so this is, remember this is just the X value, right? What is the X value? X bar means X, Y. So this is basically saying X equals 16, Y equals to -21. Okay, last question. Last question, we're given A. We'll compute the identity with matrix. Remember, identity with any matrix will be itself. Right, so 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the identity matrix. Then multiply by A, 4, 1, 1, 3, 1, 0, 1, 1, 3. We just have to show at least one dot product, right? We have 3 by 3 times 3 by 3. We should get 3 by 3 matrix. The first entry comes from this vector dot product with this one. So 1, 0, 0, dot product with 4, 3, 1. 1 times 4 is 4. Well, 0 times 3, 0, 0 times 1, 0. So we just get 4. Right, the second one comes from 1, 0, 0, dot product with 1, 1, 1, with this one. Right, you do the multiplication, you see you just get 1. So in the end, you just get 4, 1, 1, 3, 1, 0, 1, 1, 3. It's still the matrix A, because the matrix multiplied by any identity matrix doesn't change. Okay, that's all. That's the first exam. All right, good luck.